Hi, I'm DJ Ware, and today on the Cybergizmo, we're going to look at Linux file systems right after this. With all things in Linux, we have to decide when we're actually laying down the file system or installing the system for the first time. We have to decide what Linux file system that we want to use. And there are, as always with Linux, a lot of choices and a lot of things to choose from. It's one of the most important decisions that we'll make besides choosing the distro itself. So today, let's explore through the list of the most common ones. There's others besides these, but I'm just going to cover the most common ones today. So in the beginning, there was the extended file system. This was version 1. It wasn't called that, but it was introduced and created for Linux in 1992. It was based off the original Unix file system, which was the one that was deployed on most AT&T Bell Labs versions of Unix, called UFS. It was a good file system, but it was lacking in important features, and the main one being it just didn't support the larger hard drives of the day. And so I don't know if Ext appears on any distros anymore, but I do know it's no longer distributed with Linux. As far as I know. The follow-on to that was Ext2. And the extended file system version 2 offered also some good features. It expanded out the volume sizes and allowed us to go from 2 to 32 TB bytes, TB bytes, but it doesn't support journals. The range in values from 2 to 32 is dependent upon which block size you use to format your hard drive. So if you're using a 512 byte file system, then it's 2 TB bytes. If it's 4K, then it's 32 TB bytes. The max file size is 16 gigabytes and up to 2 TB bytes as well. You can still use Ext2 today. It's a good choice if you're on an SBC that requires these things, the SD card, or a USB drive. Those devices are not very long-lived when it comes to the number of writes that you can put on them. So using Ext2 is a good choice, but since it's not journaled, it doesn't write quite as much to that device, and it will extend the life of them. However, and that applies to USB, by the way, as well. But if you're going to be moving files between Linux and Windows, you might just go ahead and format these SD devices as FAT or exFAT in order to make it easier for Windows to read that, since Windows does not support Ext2 as far as I know. I don't use Windows, so if you know something different, let me know in a comment below. I'd love to hear from you. The third version was the Ext3, and it offered all the same features as the Ext2, and in fact, it is compatible with the Ext2. You could format an Ext2 drive, and you can mount it as the Ext3, and it'll work just fine. And the Ext3 does add journaling. So that's a nice thing to be able to just, migrate it to Ext3 without having to reformat the drive and then go through the steps to reload it. It also extends out the volume sizes somewhat. It goes from 4 TB bytes to 32 TB bytes for the volume size, but it stays at 16 to 2 TB bytes for the max file size. Ext4 has superseded Ext3, and like its predecessor, Ext4 is compatible with the Ext2 and Ext3. But Ext4 added features to reduce disk fragmentation through the way it manages itself in the writes out to the drive, and also how it manages the flushing of the data out as well. It kind of holds back for a while to try to minimize the fragmentation. It supports one exabytes of maximum volume sizes, and it remains. It also extends the maximum file size to 16 TB for 4K block sizes. One of the other older file systems is XFS. It was created by Silicon Graphics in 1993. That was XFS was the default file system for SGI's IRIX operating system. XFS supports parallel input-output operations. So if you're on a RAID, XFS can manage multiple IOs being spread out over the number of spindles, and it will do a good job of managing those. It also has good scalability when the drives are busy. Very good in high-performance situations. XFS is a B+ tree file allocation method, and it supports drives up to 8 exBit bytes and -1. There's a status byte that's held back that reduces it by 1 byte. The file sizes are the same as the maximum volume size. Its performance model is best with large files. Now, if you've seen my videos on Gluster, you'll know what we define as a large file. That's a file that's between 11 gigabytes and 15 gigabytes on the low end side, and then up to the larger file sizes. Anything below 11 gig, Linux considers a small file size. So if your workload is mostly small file sizes, like you're dealing with a lot of word processing documents or small graphic images, then you'll probably find your performance better with the XT4 than XFS. But if you're dealing with a lot of video or a lot of larger data sets or huge databases, unless the manufacturer specifies otherwise, XFS is a better choice. XFS is, well, it was, I don't know if it is, I haven't run Red Hat in a while, but it was the default file system for Red Hat System 7. JFS, the journal file system, was introduced by IBM for OS/2. They later ported that file system to AIX, and it has also been ported to Linux. JFS manages directories, again, with the B+ tree. It supports huge file volumes up to 32 petabytes, and max file sizes up to 4 petabytes. On AIX, there are 2 versions, JFS version 1 and version 2, but the only one you'll find on Linux is version 2. There was some speculation that IBM was no longer interested in maintaining JFS, and this was back in 2008. But the IBM Linux Technology Center, which does the maintenance for JFS, they're continuing to maintain that software on Linux. And in fact, they made a major enhancement back in 2012 to add trim support for SSD drives. However, JFS is no longer the default file system on AIX. JFS has been replaced by EXT4. So if you need the support for the large files, by all means, use JFS. I would caution you, however, you may be better off with the EXT4 simply because it has a wider range of support. It's more widely used, more widely tested than JFS is. Not saying that JFS is a bad file system at all. It certainly is not. But you may find that JFS is probably not the right thing to use in production for now. The Reiser file system. This was the golden boy. Back when it was first introduced, we thought ReiserFS was going to take the world by storm. It is a general-purpose journal file system. It is a modern file system as well. It has copy on write and other features in it. ReiserFS on Linux, however, is incomplete. It is missing the quota support, and I believe it still does. Now, when I said it's copy on write, I'm referring to Reiser version 4. And Reiser version 4 has not been released on Linux. They were working on it in 2008, and development stopped cold. Hans went to prison, and he sold namesys to pay for his court costs, and so they've been a bit of a limbo. However, I will say that they are active. The group that's left over are still making changes to it, but as of today, in September 2019, they're continuing to work on Reiser 4, but they have not merged that code into the kernel as of yet. So the other issue with ReiserFS was it did not provide any defragmentation tools with it. Now, there are third-party tools to do that, but it did not have any defragmentation tools included with it. It is in the version 5.2 kernel as a module, but is not supported as of yet for version 4. So I'm going to have to recommend avoiding it for now. I'm just not sure what its viability is going to be long term. Then there's Btrfs or Btrfs. It's also a B-tree file system. It's a modern file system, supports copy on write. It was designed by Oracle for use on Linux, and it was released in 2007. As of 2013, it's been marked as stable. Btrfs supports volume and file sizes up to 16 exabytes, and it has production support for RAID 0, RAID 1, and RAID 10. However, it does also support RAID 5 and 6, but I haven't seen anybody recommend that for production use just yet. If you have, let me know, and I will add that to the slide here. But as far as I know, those are still not officially sanctioned for production. It supports deduplication, encryption, cloning, subvolumes, snapshots, and a bunch of other features. It is very much a modern file system. It is thought that this will become the default file system for Linux, but so far it hasn't. Maybe soon that'll happen. Then there's ZFS. ZFS was developed by Sun in 2005. It supports copy on write, deduplication, encryption on BSD. It does not support encryption on Linux. It supports RAID Z. RAID Z is equivalent to RAID 5. RAID Z1 is equivalent to RAID 5. RAID Z2 is equivalent to RAID 6, and RAID Z3 has no equivalent. That would be three volume support. So it does support dry pooling and snapshots and dynamic disk sizing. However, ZFS was released as open source under the Sun CDDL licensing, and that's unfortunate because that license prohibits Linux from including it as a default file system. Ubuntu does offer ZFS support starting with 16.04, and they use ZFS by default for their containers. So if you're interested in that, you might be leaning more toward Ubuntu since they do support ZFS natively. ZFS, however, does consume a lot of RAM, and that's for the ARC. And if you turn deduplication on, those tables go right into memory, and it will take even more. I run ZFS natively on BSD. I have not switched over to Linux. And there are some reasons for that, mainly because I want the ability to grow the pools dynamically, and I can't do that yet on Linux. In other words, I can just add volumes at will to the BSD ZFS pools. And the Linux version of ZFS at the time that I'm writing this does not support that. If I'm wrong, let me know in the comments below. Be happy to correct that. If you're using ZFS to host virtual machines or supporting NFS services, I would recommend that you install SSDs as ZFS intent logs or S logs, as this will help in the unlikely event, you're right, that you suffer a system error, and it just makes the recovery quicker. As for the ECC versus non-ECC debate, I use ECC. I mean, quite honestly, if you do get a single bit error and it flips in memory, it's going to write it to disk. And that will cause disk corruption. So why take the chance? I mean, if you have ECC on, it'll correct it. But if you don't, then you run the risk of disk corruption. So that's all I'm going to say. As far as ExFAT, FAT32, and NTFS file systems are concerned, I mean, use those in accordance with your needs. If you have to mount Windows volumes, or you want to mount again SDs or USB devices that are being exchanging files with Windows, yeah. If you're reading off camera files or something like that, yep, you got that option to do that. As far as running those on a day-to-day, no, I wouldn't do that. I have run into a couple of distros that require FAT32 for the boot volume, but yeah, and in that case, then yeah, you need to mount FAT32. However, in my case, I'd be looking for another distro. I just would prefer not to. The swap file systems, those are used in Linux to implement virtual memory. Years ago, if Linux ran out of physical memory, it just crashed. Today, however, the kernel will randomly hunt down any apps. I'm not sure what the algorithm is. I'm saying randomly, and it will kill them. It'll kill those apps. However, if that app happens to be a system application, and it happens to be a service that is configured to restart on failure, you're going to get into a loop. Or that will just come right back into memory. Linux will kick it out. It'll come back in it over and over again. So just be aware of that. Should you use swap? You need virtual memory? Yes. If you want to hibernate a laptop? Yes. If you want to run out of memory and watch the algorithm try to correct itself and start shooting services that automatically restart, it's kind of funny. You can watch the spin loop occur. So yeah, by all means, leave it off if you would like to see that happen. It isn't very often that you run out of physical memory. However, I have seen systems, even with a terabyte of memory, run out of memory. It is possible, no matter what. Applications will expand to fit all available memory. That's just one of the laws of IT. I use swap files on all my servers and workstations. I prefer to use the old tried and true algorithm of virtual memory versus some new code that's in the kernel. In production environments, I wouldn't want to bet my career on randomly shooting applications, especially if I'm in a 5.9s environment. Blowing your application out of memory would be counted as downtime. And you would probably have a brisk conversation with your manager about that. So I would prefer to use something that's been around for a long time. Virtual memory goes back to the mid-60s. It is designed to solve the problem of running out of physical memory. It's worked very well for a number of years in a lot of different operating systems. So there's no need to try anything new. It's the better way to do it. It isn't that difficult to set up. So what are my recommendations for a server? Right now, ext4 for the system, XFS for the data, unless you're using small files. If you're using small files, then use ext4. For the workstation, ext4 for both the files and the data systems. I do use XFS for Gluster bricks, and those are mounted as ReiserFS. So technically, I am using XFS on a workstation. Turn swap on is my recommendation. Use ZFS for NAS, NFS, or Samba, I guess, if you have to. I'm a bit leery of using ZFS on Linux because of some of the things, some of the features it's missing currently. If you think I should stop worrying about that and I can safely go over and use it, great, let me know. I'm not close enough to the using the ZFS on Linux side of things. I use it on BSD. It's solid, and I don't have any problems over there. So if ZFS would become native on Linux, I would switch my recommendation out for ZFS instead of ext4. But right now, I'm waiting for Btrfs to make it to the default file system install for Linux. So once that happens, I'll replace all my ext4s with it. So with that, I hope you enjoyed today's discussion, and I look forward to hearing your comments. And please let me know what you use and why. I would be interested to talk that with you and see how you're doing with things. Again, my recommendations are based on servers and workstation production environments, not home use. So if you have a favorite file system, let me know. I'd be interested to hear what you're using. Thanks again for watching. If you do like this, please comment, like, and subscribe, and hope to see you all again real soon. Bye for now.